All right, let's talk about graphs and linear relationships. How does the graph of a linear relationship look? What does it look like? Remember, it's a straight line. Straight line. Linear means line, and a linear relationship has a graph that's a straight line. So any straight line represents a linear relationship. It can be going up, it can be going down, as long as it's straight. How is the graph of a proportional linear relationship different than just any other linear relationship? Proportional relationships, remember, are the special kind of linear relationships that its graph will be going through the origin. And remember, the coordinates of the origin are 0, 0. So it's a graph that's going to be going through 0, 0. All right, if we're going to describe how to find the pattern of change or the rate, if we have a proportional graph, remember this strategy only works if it's proportional, which means it's going through the origin. Those are the easy rates to find, because if it's proportional, then you can just go to 1 on the x-axis. You can go to 1 on the x-axis. And then up or down until you hit the graph. And then read the y value. So that's one way you could describe it. So what we're doing, remember, we're going to go to 1 on the x-axis. So there's 1 on the x-axis. And then you're going to go up or down until you hit the graph. In this case, we're going to go up. And then read the y value. So if I look at this point where I've hit the graph and go over here to the y-axis, the y value in this case is 1, and that means the rate is 1. The y value is 1, and so in this case, in my example, the rate is 1. All right, if you want to find the pattern of change on a graph that's not directly proportional, it doesn't go through the origin, you can use a similar strategy. It's just you can't go to where 1 on the x-axis is this time. You need to start anywhere on the line, really. Start at any point on the line, on the graph. Okay, so pick a nice, pretty point that's, on the crosshairs. So once you've found that point, then you can move 1 unit to the right along the x-axis. Okay, so instead of starting at 1 on the x-axis, you're going to start at a point and then move 1 unit along the x-axis to the right, and then you're going to do the same thing. You're going to go up or down to hit the graph. And then again, instead of just reading the value on the y-axis, you have to see how much you went up or down on the y-axis. So it's a little bit different but very similar. See how much you went up or down. Okay, so now I'm going to demonstrate. I'm going to pick any point on the graph that looks nice and neat. Okay, right there looks good at the 0.34. And now I'm going to move over 1 unit to the right along the x-axis, and then I'm going to go up until I hit the graph, and I'm going to see how much did I go up along the y-axis. Well, I was at 4, and now after moving over to the right 1 and up 1, you can see I'm now at 5. So how much did I go up along the y-axis? I went up 1. So in this case, my rate is 1 because I went up 1 unit on the y. So you can think of that as how much I changed in the y direction for every 1 unit I went along the x, or the change in my x value. Okay. All right, next, how can you tell from the graph where a linear relationship starts? Now notice I'm using quotes because where it starts isn't really accurate because it doesn't start anywhere. A line goes on forever in both directions, so it doesn't really start anywhere. But what we mean by that is where it's going to be crossing the y-axis. Where it starts is where it crosses the y-axis. And why do we call that the start? Because that's where the value of x equals 0. And x is our independent variable, so if we're thinking of the starting of a problem, where the independent variable starts at 0, when the story begins, when time starts, when the number of t-shirts is 0. You know, I haven't bought anything, I'm just starting to buy t-shirts. So that's kind of why we call it where we're starting. But keep in mind that a line goes on, the graph goes on forever in all directions, it doesn't really start. But when we are talking about start, we're talking about where it will cross the y-axis, and that's wherever y is, or excuse me, wherever x is 0. So in our example above, that graph starts on the y-axis at y equals 1. So it starts at 1 because that's where it crosses the y-axis. Now what if we have a linear relationship that has a constant change of 0? So there is no change. It changes by 0 every time. What does that look like? Well, remember that's our horizontal line. Horizontal line. Horizontal, remember, the horizon goes back and forth. It's parallel to the x-axis. Now describe the graph of a linear relationship with a negative rate of change. So something's happening over and over again, but it's going down over and over again. It's decreasing. So if it's decreasing, then the graph is going to go down. The graph goes down. And what we mean by that, when we're talking about the direction of a graph, we're always thinking about it as we move from left to right. Just like we read, just like our number line increases as we go from left to right. So when we're reading a graph, we're moving from left to right as if we're walking along the x-axis, continuing to go up by 1 on the x-axis. So if I want to draw a graph that has a negative rate of change that's going down, if I were to start on the left along the x-axis and I continue to move to the right, that would be a graph that's going down. It's going down as I move from left to right.